Thanks for joining us today at FM3 Design for discussions about patch cords and extension cords for the shop. Patch cords, short cords, cheater cords that we use in our shop to help connect various things when we're out in the field and also when we're in the shop. Now today I've brought samples from Hubble, which we got from Graybar Electric, as to give you an idea of the typical things that we use here and hopefully you would use in your situation too. Most of the welders come with a connection that looks like this, which is a 50 amp single phase, or you call it two phase circuit. So notice on the backside is got good connections and stuff. None of the pins wiggle, they're all solid. Where a lot of the ones you buy, the pins you drop into pins, whether or not it's a 40 or 50 amp by moving the pins around. So this being a connector that we prefer to use, we do have some that are not at this level yet. We're changing them out as we move along, as we use them from time to time. So again, the connector here is Hubble, and it's 50 amp, and we use these. This is typically what gets on your when you buy a welder, or you would put on a welded plug. Typically a stove type plug is what that would be. Now we move down to 30 amp. So basically we kind of settled on 30 amp and 50 amp in our environment, since a lot of our tools are 20 to 30 amps, and then we have the larger ones that are 50 amps. Now this is again single phase, and they're marked 30 amp, 250 volts, and they are a nice, good quality connector. Again, Hubble. And if you take a look at the back side of them, you'll see that they have guides for the wires, and the wires fit in very tightly, and both of them are about the same as far as that goes. Again, in 220 volt, in the 3-wire configuration, we have the cold and 2 hots. So that's how that works. That's why I have 3 wires. You can have a 4-wire configuration that has a neutral safety ground in it that is available also. That takes obviously a different connector. It's a 4-wire single phase 220 volt connection. So in these are the primary 2 connectors we use. We use the female, which I'll bring up here in a moment. Now, the female connection that I'm using here, and this is going to be replace one of our existing connectors that's on the extension cord that we use, and I call them extension cords, although more likely not they're referred to as SO cord. SO being a type of cord that is used as quote-unquote extension cord, heavy rubber jacket and larger connectors. The important here is that this one, being a good quality, has good stainless steel cover, a high quality connection for the, again, stove-like plug, and then the aluminum box. Now this happens to be a cord with a strain relief. This actually hangs onto the cord to make sure that you don't accidentally pull a cord out of the outlet or damage the outlet, or run the risk of pulling the cord loose and then getting shorted or shocked or something like that. Again, when working around electricity, safety first, and safety is primary. So that's the big thing with that. So again, this connection would fit in the box with screws, obviously, and fit like such. And the cord would go in here, make your connections appropriate. Please note that when making the connections and you take the jacket off the cord and off the copper conductors, do not cut the copper conductors, because they, in this case, electricity flows over the outside of the copper, not the inside. So, and now mind you, it's opposite of water. Water flows down the inside of the hose, but electricity flows down the outside of the wire. So just so you note that. Now notice that this connection here will fit in here correctly, so it's a 50 amp to 50 amp connection, and that's what you do. So we run into a scenario that happens occasionally, and that we need to adapt to or from 30 amp to 50 amp. Even though the plug's 50 amp, we're not going to use all 50 amps. I've got a welder that's got a stove-like plug or 50 amp plug on it, and I'm only going to weld at 100 amps. I don't need 50 amps for the 100 amps. A lot smaller connection is appropriate. Hang on as I grab one of the cords and we'll take a look at that. So this is a unique cord that we make, or we made to use, and the plug on the here is 3 blades, and that's typically a soap plug, dryer plug for 50 amps. Then the one over here again is a stove plug. So if you work at a location and the customer's got 3 blade plugs like this, and your equipment uses the stove-like plug, you have to make an adapter cable. That's what we did. So we got a short piece of SO cord, put both plugs on that, matched up what we did. Again, matching the wiring correctly. If you have questions, go to YouTube or Google and get the information you need. There's plenty of information out there. If you have any questions, give us a holler. We'd be glad to help. So that's one of the cords. Now we'll get you a sample of a different cord. I took this one apart so you'd have an idea what the connections look like on the back side. So here's our neutral going to earth ground. I have black and white. They're both 110 volts each. Here's the 30 amp plug that matches the 30 amp plug here. So I've got my welder stove-like plug that's going to need to have, let's say 25 amps is all. Well, I can use a 30 amp circuit. I match my wire size and length to the amperage and voltage that I'm going to use. So just because you have a 50 amp plug doesn't mean it's going to pull 50 amps all the time. You need to watch what it is, understand your equipment. If you have any questions, again, give a holler. We'll be glad to help. So this is 30 to 50, so I can plug into a 30 amp outlet with an adapter and come to 50 amp plug. Okay, we'll get another one up. This one's another unique one here. This happens to be a generator-like plug because a lot of the generators are designed that are lower end, and we're not talking a $10,000 generator, we're talking a $1,000 generator that power motorhomes for air conditioning and stuff like that. So this is a 30 amp plug, or 20-30 amp plug for generators for the motorhomes, and then this is my 30 amp plug that connects to my equipment. So instead of having a 50-foot extension cord with this plug on this end and this plug on this end, I have a short one. I only have one 50 amp or 50-foot plug that is 30 amp that goes from this short adapter cable to the equipment that I'm being used. Hang on, we'll take a look at another one. One of the customers had a situation that they had a 4-wire 220 volt outlet that had a neutral ground in it. Well, my equipment doesn't have a neutral safety ground equipment in it. So I adapted from his 4-wire to our 3-wire so we could use the extension cord and again power our equipment that we're used to powering. Again, safety first. And here's another good example of not a good quality plug. As you can see, the things wiggle a little bit. It's not really good, not good connections. There's metal in the pieces and stuff. Inexpensive plug. We had to have it in a hurry one day, and somebody ran off and picked one up, and I went, oh my gosh, you didn't go to Graybar. And he said, well, it's too far to go to Graybar, so I just grabbed what I could. But we need to get from a 50 amp plug to our 30 amp because we're using lighter equipment, and we're running out there quite a distance. So again, another adapter cable, 50 to 30, and all in that single phase 220 volt. And then we run in a situation, we're out in the boonies, we're about 60 feet away from the generator, can't get the generator any closer, but I need to have a grinder. It needs to have 6-7 amps for a grinder. Not much, but still need to get the job done. So consequently, made an adapter plug that went to 220 volt single, only took the neutral and one leg of the 220 volts, gave me 110 volts, and powered this. The other leg, I left it disconnected. So again, it's just a quickie, dirty little way to get power out there for grinders and buffers and little equipment like that. And if you're working at night, you can hook a nice big bright light to it and you won't be standing in the dark. So again, safety first. Safety is everything about what we're doing. Now, one of the things that I do is that I like to have good quality screwdrivers to do the work with. So these are Klein screwdrivers, and the orange on them is an insulation material that's voltage rated to keep you from getting shocked or getting yourself blown up. Again, be real careful when working with screwdrivers that you work close enough to you can see what you're doing. Make sure you got good light. Don't probe around in the dark, especially working on a panel. You can get, it can cause you to become the last time you get to do it. So be careful with that. The other thing that I do insist on is gloves. Now these are really nice gloves. Now these are regular electrical safety gloves, and these actually have a rating on there called SAS Safety Corporation, maximum use voltage 1000 volts. So these are actually protected, will protect your hands up to 1000 volts with that. Now the reason that it's rubber on the inside and leather on the outside is you still need to have something that is not going to puncture the rubber and cause you to short out. A lot of companies test the gloves, and they have special equipment to test the gloves to make sure that they do not have punctures or holes in them that can cause a person to get shorted out or electrocuted. Now, one way you could do that, and of course mind you, it takes a little time to get everything dried out and cleaned up, but you could actually fill these with water or put them in a water-filled container and weight it down so it fits in there, and then make sure it's not anything that's going to puncture it, and then feel if there's any moisture comes through, because that typically what's going to be the issue. If you have any questions, it's cheaper to buy new liners or new gloves than it is to take and run the risk of getting hurt. So that pretty much covers the single-phase electrical side of the connections. We'll cover the three-phase in another video. So appreciate your time, and have a great day.